Hello everyone. In this video, we're going to finish up Lesson 8 by talking about the specific the specific steps for a hypothesis test for proportions. All right, so the first step should be the parameter of interest. What are you looking for? For a hypothesis test for P, it's going to be always P, but you need to define what P is in terms of the problem. Okay, the proportion of heads of a coin. Okay, the proportion of winners of a Coke winner bottles in a Coke competition. Okay, in a Coca-Cola bottle competition. So on and so forth. Okay, so that's the parameter of interest. You identify the null and alternative hypothesis. Okay, and so here's the options with symbols instead of actually numbers. Okay, so the null hypothesis is always going to be P equals some number. I call it P naught here. Okay, just for fun. And then the alternative hypothesis, I have three choices: less than, greater than, or not equal to. Right. Third step, level of significance. Again, that's specific to what the problem says. I set alpha equal to some number. All right. Step 4 are the assumptions. What are the assumptions for a hypothesis test for P? The first is that the data is taken randomly, and the second are those sample size conditions that we should be used to by now. Okay, so they change slightly for every situation that we've been in. Okay, for this situation, the sample size conditions are n times P naught, and that P naught is the hypothesized value. Okay, so n times P naught is greater than 15, n times 1 minus P naught greater than or equal to 15. If those are met, we can move forward. If they're not met, then we can't. Okay, and so if they're met, then I can assume that P hat has this normal distribution. Great. This informs us of how to make the test statistic in step 5. So here we are. Our test statistic looks like this. Z, we're going to call it Z, equals P hat, my observed sample proportion, minus P naught, divided by the square root of P naught times 1 minus P naught divided by n. Okay, that's the standard error of that sampling distribution. All right, so that's step 5. Step 6 is problem specific. Okay, it's the p-value, and so I've put here 3 different options, and they correspond to alternative hypothesis of these things. Okay, so actually they should be flipped. Okay, they should be flipped. Let me change that very quickly here. Nope. This one should be over here. Okay, this one should be over here. So sorry. Here, all right? So you'll notice, although it doesn't really matter to you that much, okay, this is sort of just for understanding purposes. Actually, when you do a hypothesis test, we'll always or almost always use technology, okay, to do this. So you might be afraid at this point that you have to do all these computations by hand. Most of them, yes, okay, but technology will help you. So you'll notice that the inequalities inside the probability statements above match the inequalities in the null hypothesis, okay, except for the not equal sign, okay. There I have to multiply the probability by 2, okay, because things can be odd in both directions. Okay, it can be a lot larger than I thought it was, or it could be a lot smaller than I thought it was. Whatever the I thought it was. Okay, the proportion. So the proportion can be a lot bigger or a lot smaller than I thought it was. And so I need to multiply the probability by 2 in order to get the proper p-value. Again, you don't really need to worry about that. If it doesn't make sense to you, technology will do it. So there's the p-value. Step 7, the decision and conclusion, are, again, problem specific. All right? So let's do an example. So this will be the first time where you actually get to see all of these steps in action. So this will be extremely important to us in trying to understand what the heck's going on. So the CEO of a large electric company claims that 80% of his 1 million customers are very satisfied with the service they receive. The local newspaper is not so sure, so they want to test this claim. To test this claim, the local newspaper surveyed 100 customers using simple random sampling. Among the sampled customers, 73% say they are satisfied. Based on these findings, can we reject the CEO's hypothesis that 80% of the customers are very satisfied? Use a 0.05 level of significance. So, the first step is to identify what parameter we're talking about. We're talking about P, which in this case is the proportion of all customers of the electric company who are satisfied. Okay, that comes from the problem. Step 2 are to identify the hypotheses. Okay, so for this hypothesis, the null hypothesis is easy. Okay, the CEO claims that 80% of his customers are satisfied. Right, so that's the null hypothesis claim, that the proportion P is equal to 0.8. The tricky part here is which of the 3 alternative hypotheses could I use? Greater than, less than, or not equal to? We have to choose this before we actually look at the data. So I can't look at 73 and say, well, that's less, so the alternative hypothesis should be less. Because it doesn't tell me a direction, okay, it doesn't say that the local newspaper thought that it was less than that. Because it doesn't tell me a direction, I'm going to use not equal to. Right? If it said the local newspaper thought that it was actually greater than its claim, than the CEO's claim, then we would say greater than. If it thought that the newspaper thought it was lower than that, we would say less than. Okay? But it doesn't give us a direction, so we'll say not equal to. You could argue that it should be less than, because a CEO is never gonna understate his level of satisfaction, or the customer's level of satisfaction, but they might overstate it. That is true, okay? But for this one, I'm going to say not equal to. The third step is the level of significance, and it says in the problem, use a 0.05 level of significance. So I set alpha equal to 0.05. Step 4 are the assumptions, okay? Was the data taken randomly? It says using simple random sampling. Okay, so yes, the data was taken randomly. And then sample size conditions, 100, so it took a sample size of 100. 100 times 0.8 is 80, which is greater than 15, great. And 100 times 0.2 is 20, which is greater than 15. So all of the assumptions are met, we can move forward. All right, so we move forward to step 5, which is calculating the test statistic. And so the test statistic is p hat, the sample proportion, which is 73, stated in the problem, minus 0.8, which is the null hypothesized value, divided by the standard error of p hat, assuming that the null hypothesis is true. So you'll notice that we use 0.8 and 0.2, and not the 0.73 and 0.27 p hat and 1 minus p hat, okay, for the denominator stuff there. When we do that calculation, we get that the z-score is negative 1.75. So then we move to then we move to the p-value step 6, okay? And so I put in the z there, okay, of negative 1.75, and I say 2 times the probability that z is less than negative 1.75. You'll notice that it was less than before I said it was greater than. It can actually flip depending on the sign of the z-score. Again, we don't really need to worry about that. I'm just putting it here for completeness sake. The p-value, what comes out is 0.08. Okay, so that means there's an 8% chance to see what I saw or something weirder, given that the null hypothesis is true. So the decision happens when I compare that p-value of 0.08 to the alpha level of significance, which is 0.05. You see that 0.08 is larger than 0.05, so I fail to reject the null hypothesis. Okay, I fail to reject the null hypothesis. And so what that means, this is the conclusion, at the 5% level of significance, or the 5% significance level, there's not enough evidence to suggest that the proportion of all customers of the electric company who are satisfied is different than 80%. Okay? That is a full hypothesis. You should do all of the steps in this slide, okay? Not just some of them, all of them. And so here's an example. So here's a reading assignment to get more on hypothesis testing. I really suggest that you do the reading assignment. And here's a your turn. Okay, so I give you the same setup before. I'm still interested in the Marvel superheroes that we talked about in the last your turn. All right, I give you a sample and I ask you to do a hypothesis test. All right, so that's the end of lesson 8.